is Micha, and for today's video, I will be performing experiment 1, basic logic gates, featuring and, or, and not gates. So, if you'd like to learn more about these logic basic gates and how it actually works, just keep on watching.
Breadboard, connecting wires, IC, 7411 triple input AND gate, 7408 AND gate, 7432 OR gate, and 7404 hex inverter gate. 5-volt power supply, LED, and a 360 ohm resistor. We can see from the data that the output is opposite from the input. This is mainly because the IC used is an inverter. 7404 is a NOT gate IC that consists of 6 inverters which performs logic invert function. With that being said, that makes our data valid since the input logic was inverted. For the data in part 2, we can see that any high input will give us high output automatically. However, with the presence of both zero input, the output is zero. This is how an OR gate IC functions. Here in part 3 of the experiment, we use 7408 AND gate IC. We can see that an AND gate IC will give us a low output automatically when given an any low input. However, with the presence of both one input, the output is 1. This is how an AND gate IC functions. This part of the experiment uses multiple input AND gate. Just like in the previous two input AND gate, the data shows the same result. With any low input, it will already give a low output. We can see here that if there is one logic 0, the output is automatically 0. However, if all input is 1, the output should be 1. This part of the experiment uses AND or combination of IC. Based from my own observations, with pin B and C connected to an AND gate IC, any of these pins that has an input of 0 will automatically give an output of 0 if the input for pin A is also 0. However, if pin A, which is connected to an OR gate, has an input of 1, we can apply the function any high input will give high output. Thus, any combination of the three inputs with pin A is 1, the output will automatically give 1. Lastly, we can see that all three input of 0 will give an output of 0, and same goes for all three input of 1 gives an output of 1. This is the output logic gate for part 6. Using the full AND, OR, and NOT set of logic gates, we can create the Boolean expressions for the exclusive OR, XOR, and the not exclusive OR, XNOR gates. However, this topic is covered by universal gates, which will be featured on my next video, which is the experiment 2. So stay tuned.
So that's it for today's video. Thank you for watching, guys. I hope you learned something from my video. And if you like this video, please give it a thumbs up and don't forget to subscribe to my channel. Thank you. See you. See you.